Finally, to summarize the different kinetic models, this table puts them together. We would have the nucleation and growth model follows the JMA types equation, and the n factor, the n factor would be from 1 to 4 depending on the geometry of the nuclei, the nucleation mode, whether it's constant nucleation or site saturation, and whether the rate limiting step would be diffusion or interfacial reaction. So this would be the nucleation growth model. And earlier we also said the diffusion controlled one-dimensional model. Of course, I've fraction conversion square would be kT. Of course, this is only applicable for low conversion. And we also just mentioned the two model. One is diffusion controlled three-dimensional shrinking core model, the Genders equation. The other one would be interface controlled shrinking core model, which we give it here. And the n value can take different number, 2 for two-dimensional growth or shrinking area, and 3 for three-dimensional or shrinking core or shrinking volume. Okay, and some other models include the power law model, which means the fraction of conversion would be kt to the power of n, and n can be 1, 2, or 3. Okay, if n is 1, that's first order, n is 2, second order, n is 3, that's third order reaction. Of course, all these are only for the beginning stage of the reaction, because when t goes towards infinity, the real fraction can only be 1, but according to this equation, it can go towards infinity, which is not true. That's why we said this equation is only applicable for the beginning stage. Okay, similar for this one, the diffusion controlled one-dimensional growth. And the reaction order model, the fraction, the derivative fraction of conversion with respect to time would be a constant times 1 minus f, the unreacted fraction to the power of n for first order or for second order. Okay, so we have all these different reaction models, and they all, as we mentioned, have certain assumptions related with them, and they describe different things. Nucleation and growth are more concerned with starting from locally from small, while all these shrinking core based model are quite often for the large scale global or microscopically description of the reaction process. And the power law or reaction order are quite often, or diffusion controlled 1D model are quite often for the beginning stage of the phase transformation. Okay,